morning. Today's lesson is on 2.3, misuse of statistics. And we're going to start with an activity. I will post this activity in the Google Classroom for you to follow along with me if you'd like. All right. After Apple Computer introduced the iMac, the company wanted to know whether the new computer was expanding Apple's market share. Was the iMac mainly being bought by previous Mac owners, or was it being purchased by first-time computer buyers or by previous PC users who were switching over? To find out, Apple hired a firm to conduct a survey of 500 iMac customers. Each customer was categorized as a new computer purchaser, a previous PC owner, or a previous Mac owner. The table below summarizes the survey results. So they have total 500. 355 were previous Mac users, 60 were previous PC users, and 85 of the 500 were first-time buyers. Okay, so question 1. Here's the clever graph of the data that uses pictures instead of more traditional bars. How is this graph misleading? So what do you see in this picture besides just the data that was given in that last chart? My eyes are drawn to the area of the computer instead of the height of that computer. That makes it look like the Mac is way bigger than the Windows or the None. Consider the two possible bar graphs below. Which one is considered deceptive and why? Okay, so they show the exact same information, but doesn't PC look smaller over here? Well, why does PC look smaller than it does here? If they have the same information, why does this one look smaller? Look at where we start. We're starting at 10 right here instead of at 0. So it makes these bars look smaller. It makes it look like there were a lot less PC users. A clever marketing consultant excuse me, wants to advertise the results of the survey as over 40% of new iMac owners are former PC users. The consultant got this figure as follows. 60 divided by 45 is 41%. Why does this distort the truth? Okay, so if I consider a percentage as the part over the whole, 60 is the part, the whole would be 500. So the true percentage is 12%. They used 145 as the whole, which makes the percentage larger. Okay, a line graph displays changes over time. The time is on the horizontal axis. The variable being measured goes on the vertical axis. For example, if we measure the height of the growing child, so if we put the time on the x-axis and the height on the y-axis, when we go to the doctors, we get height measurements. Okay, so we put these points on there. When I connect those points with a line, doesn't this line have meaning? This line says that between these 2 points, this little kid has grown from height A to height B. Okay, so can I make a line graph out of any information? Let's use books down here. I forgot an O. There we go. I'll add a little O in there. Let's use books down here, and let's say 1 book, 2 books, 3 books. Okay, if I put a point here on 1 book, a point on 2 books, if I connect those points, does that have meaning in between? Could I have read 1.5 books? Sure, I could do that. Okay, so let's come up with another example. What if we put, let's say, I don't know, we'll put time on the x-axis, so that makes sense. But what if we have, people on the y-axis, and I have 1 person, I have 2 persons, at time, let's say 2, can I have 2.5 people? No, I can't have a half a person. People are in whole units. I can have a discrete graph here. I can put dots. I can make a discrete, and the dots would have meaning on this, but I can't connect those with a line. Okay, trends. We can have a long-term upward or downward trend over time. We look for trends in an overall pattern. So for example, in this scales in millions, and then we have the years. There's a little bit of a downward section right here, but overall, from the beginning to 1998, we would say this has an upward trend. Okay, and here we have a little bit of an increase, but overall, through the years, this has a downward trend. There is not a right scale, but the scale needs to be chosen because it can affect the way the graph looks. So for example, this is the exact same data. And the scale here, we counted by tens, and here we're counting by fives, okay? So I can see a lot of what's happening in the data a lot better because it's not all clustered around a couple of points right here, right? I have a better understanding of what's happening when the scale is more appropriate. Okay, changes over time that have a regular pattern that repeat at the same time each year. So if we look at our gas prices, okay, our gas prices increase during the summer months. Every year, the summer months are June, July, August. Look at the increase in every year of gas prices, and then it goes back down when kids go back to school, and then it increases again for December for travel time, and then it goes back down while kids are in school, and then it goes back up again in the summertime while kids are out of school. There is a seasonal variation in the changes that occur in the gas prices. A pictogram is using pictures to represent a count. So for example, I've got fishies here. It looks like the San Gabriel fishies and the Nile fishies are the same because they have the same, they end here at the same, but they have a different starting point, right? So the Nile is actually bigger, okay? The key is 30 fish caught per day. So the drawbacks are we might look at the height of the bars to compare which river has the most caught per day, and our eyes will react to the area as well as their height. So let me give you an example. So in this example from your textbook, the key is each one of these pictures represents 50 people. But if I just look at this really fast, I automatically see that horses is the highest. So I think that horses has the most. And that's not true. Horses have 150. Okay, that's the same as these fishies down here. They're both 150. But this looks like it's the smallest amount, and this looks like it's the biggest amount, which is both deceiving. Now, if I look at the dogs and the cats, right off the bat, when I look at this, I'm going to think the dogs are more. But when I count 5, 10, 15, 20, 25, so that's 250. Okay, and let's count here, 5, 10, 15, 20, 25, 30, 35, so that's 350. So actually the kitties are a lot bigger, a lot more people have kitties than do doggies. So this pictogram is very, very misleading because it doesn't tell a whole picture. Okay, if I look at the same information with the bar graph, can I see very clearly when I look at this bar graph, cats are the highest, then dogs, and then horse and other are equal? It's more clear. I can see better what the data is trying to tell me. Okay, make sure you label your graphs. Include the title, a legend, or a key if it's necessary. Make sure you label the axis, include times of measure. Make sure that the date is included in the title. Make the data stand out. Eyes should be drawn to the actual data, not the labels or the grids or the background art. You're drawing a graph, not a piece of creative art. Okay? Pay attention to what the eyes see. Avoid pictograms. Choose your scales wisely. Avoid 3D effects that might confuse the eye. They might look really cool on the computer, but if somebody has to take a second to think about what it's trying to show you, the message could be more clear. Okay. Graphs are an important visualization of data. It's easier to see trends on a graph. The things that we need to ask ourselves: when was the data produced? Exactly what was measured? What did they not tell us? What's the most common way to mislead with data is to cite correct numbers that don't tell the whole story. Are their numbers plausible? Do they make sense? Okay, so for example here, Crested Butte attracts skiers by advertising that it has the highest snowfall at any ski town in Colorado, which is 100% true. Crested Butte has the highest snowfall in any ski town in Colorado, but the ski slopes are not in town. There are many other ski resorts that get more snow on the slopes, but people are going to get the wrong message from this ad. Okay, so what is it that they want to happen? They want people to come to Crested Butte. So they are telling a true statement right here. This right here is the exact truth. It's 100% true. They are not lying. They are not misleading, right? However, you have to be really careful. Okay, are you skiing in town? Is that where you want to go skiing? No. Okay, you're skiing on the slopes. So I want to look for the highest snowfall on the ski slopes. And then I want to ask, is this possible? A very respectable journal in science, in an article of insects that attack plants, mentioned the California fields that produce 750,000 melons per acre. Wow, that's a lot of melons. Okay, but I don't really know much about an acre. So let's do some math. If I look at melons per square foot, will be melons per acre divided by melons per square foot per acre. Okay, sorry, square foot per acre. So I have 750,000 melons for 43,560 square feet per acre, puts 17.2 melons on the size of a desk. Okay, so a square foot is about the size of your desk at school. There's 1 foot here and 1 foot here. Can I fit 17 melons on the top of your desk at school? Okay, is that plausible to grow 17 melons in the space of a desk? Well, no, that's not possible. Okay, so I have to be really careful of what information I'm seeing and what information is actually true. That was actually a typo in the journal. They had to go back and fix that. Okay, calculating percent increase and decrease. A quantity can increase by any amount. 100% increase means that it's doubled. A quantity cannot decrease by more than 100%. If it's lost 100% of its value and 100% is all that there is, I can't lose more than I have lost. Okay, so I can increase with no bound, but I cannot decrease by more than 100. Okay, so the formula is percent change is equal to the amount of change divided by the starting value times 100. Okay, so let's do an example. In 2008, the NASDAQ index of stock prices dropped from 2,653.91 cents to 1577.03. What percent decrease is this? So I want to think about this right here. I want to think about this value and I want to think about this value. Okay, and I want to find the change in those two values. So I want to look at the final and the initial. And something I've learned over the years is that I need to change these words. So I'm thinking about final as the end value, the new value. The initial is the old value. So I want to do my new value minus my old value. The initial is your starting value. That's what I started with. That was the old value. The new is what I changed to. So my amount of change, I want this to be my new value minus my old value. My starting value is my old value. My starting is where I started at. It's the old value. It's where it hasn't changed yet. Okay, so I drop from 2653. That's my initial value. My initial value is my old. Okay. My starting value is where I started from. So, sorry, this is where I stopped, not where I started. This is where I stopped. This is my new value. So I ended up at 1577. I started at 2653. So I went from 2653 to 1577. So I'm going to do my new minus my old. Okay, so my new is the 1577.03 minus the old, and I'm going to divide by the old. Now, this is going to be completely politically incorrect, but I hate saying this on a video, but I will say it because it helps you remember it. So when people get old, they pass away. And when people pass away, we bury them in the ground. Oh, I'm sorry. I know that that's completely politically incorrect. So that's how I remember which one goes on the bottom. Okay, we bury our old. Okay, so when I subtract 1577 minus the 2653, I get negative 1076.88. Divide and multiply. The percent change is 40.6%. The negative just means that it's a decrease. So what percent decrease was this? The percent decrease is going to be 40.6. We dropped the negative sign. The negative just tells me that I was decreasing. If it was positive, I'd be increasing. And look at that. I wrote it there. Okay, the stock prices decreased by 40.6%. Okay, Anne works in a supermarket for $10 per hour. If her pay is increased to $12, then what is her percent increase in pay? So before I bring up my formula, okay, let's think about what's the new and what's the old. Okay, we work for this much money, and they change my pay to $12. What's my new pay? Is my new pay the $12 or is my new pay the $10? My new pay is the 12. Okay, that means my old pay was the 10. So that's my new, and that's my old. If I plug that in, my new minus my old is 12 minus 10. Vary the old, that's going to be divide by 10. So that'll be 2 divided by 10 is 20%. 20% is a positive number, and that means I'm increasing, so that's what I wanted to find. So I had a 20% increase. The staff at a company went from 40 to 29 employees. So I want to look at this 40 and I want to look at this 29. What is my new number of employees? My new number of employees is the 29. My starting number of employees, my old value was my 40. So if I want to do new minus old, okay, my new was 29, my 40 was my old. Plug it in, 29 minus 40, divide by my old, so divide by 40. Do the math, and that gives me a 29.7% decrease. Why did I drop the negative? The negative just told me that I was decreasing. Okay, example 3. At a supermarket, a certain item has increased from 75 cents per pound to 81 cents per pound. What is the percent increase in the cost of the item? Okay, so my formula for percent change is new minus old, and I'm going to bury my old, times 100. So my new value is the 81 cents. My old value is the 75 cents. When I plug that in, 81 minus 75, I'm going to bury the old, so divide by 75. That's going to give me 6 divided by 75 times 100 is 8%. So my increase in the cost of the item is 8%. Okay, so when I did this, it's going to give me 0.08. When I move that over 2 places, that's how I got the 8%. So this fraction right here, 6 over 100, is 0.08. When I'm talking about timesing 100, I'm talking about moving the decimal place 2 places. Okay, so your homework is the practice problems 2.3. I used page 92 and a couple of other places in the textbook, but mostly from page 92, numbers 59 through 65. You do not have to do those particular problems. They are already put into the practice problems on the Google form. Thanks, guys. Have a good day.